Hello juniors, today we're going to continue with electronic assignment number 4, which is about Venn diagrams. Remember from last class we have seen the basic definitions of a Venn diagram, what each of the elements represent, how we represent the universe, how we represent a particular event. We have also seen the definition for complementary events. Remember that the complementary of an event plus the event, the probability of the complement of an event plus the probability of the event itself is always equal to 1, right? Which is what we have here which is also available in the formula booklet, right? And then we have the intersection of events, which basically is what two events have in common, right? And we have seen also union of events, which implies all of the different possibilities from two or more particular events, right? So the word that defines union is or, that's the clue word, while the word that defines intersection is and also the word but, okay? But is also used for intersection. Then we have made a short example where we applied all of these concepts. And now we're going to continue with the addition rule. The addition rule, also known as combined events. So pay attention to the following example. It says, here's the Venn diagram for the students who do archery and badminton. So once again, we're following the same example. A is for archery, B is for badminton. And if we want to find the number of people who do both, or who do archery or badminton, remember that is the addition of all people who do archery plus all people who do badminton, but then we need to subtract 1 time what we have in the middle because we're adding that term 2 times, right? If I add 22 plus 16, this would be archery, 16 plus 14, that would be badminton, but then I will have to subtract 116 because I'm adding the same thing twice, right? So that is where this formula comes from, basically. So it says 38 plus 30 minus 16. 38 is archery, 30 is badminton, and this 16 is one intersection between A and B, right? One intersection. So it says that the number of A union B is number of A plus number of B minus number of A intersection B, which is what I just showed you, right? So the probability of A union B, that's the probability of the union, is probability of A plus probability of B minus the probability of the intersection, ones, right? Because of the repeated value we have. And this is the formula for combined events. If I want to find the union between two events, I can apply either this formula, or if I am able to draw the Venn diagram, then we know that the probability of the union is the addition of all of these 3 elements divided by the universe, right? In this case, I think the universe was 100 maybe. I think it was 100. Okay. So here it says, the probability that a student does archery and the probability that a student does badminton each includes the probability that a student does both archery and badminton. We only wish to include this probability once, so we subtract one of these probabilities. That's why in the combined formula we have the combined events formula. We have that subtraction over there. This formula is available in the formula booklet. Let me show you. If you go to the formula booklet, we have seen the formula for probability. We have seen the formula for complementary events, and this is the new thing you're learning today: the formula for combined events. Probability of A union B equals probability of A plus probability of B minus 1 time the probability of the intersection. Okay, so if we go back, let's see some examples. But before doing the examples, this is something basic that I assume that all of you know, but in case you don't know this, this is how a deck of cards is organized. It says, in the next example, you need to be familiar with an ordinary pack of 52 playing cards. In a pack, there are 4 suits, like 4 different shapes, right? Which are clubs, spades, hearts, this one, and diamonds, okay? 4 different types of cards. Then it says, the clubs and spades are black cards. So we have 2 colors, black cards and red cards, right? Hearts and diamonds are red cards. There are 13 cards in each suit. The ace, which we consider to be 1 normally. And then 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king, right? The jack, queen, and king are called the picture cards. Are playing cards in your country similar? Okay, whatever. So this is the important thing you need to know. We have 52 cards. There are 4 different types of cards and 2 different colors, right? Red and black. And for each of the categories, for each of the suits, we call it, there are 13 different cards, right? From A to number 10, and then jacks, queens, and kings. Okay, so by knowing that information, we're going to be able to solve this example over here. So let's see. It says, a card is drawn at random from an ordinary pack of 52 playing cards. Find the probability that the card is heart or a king. Okay, so I'm going to apply the formula we have just deduced from the previous demonstration right here. And I'm going to rewrite that formula here. It's probability of, I'm going to call, in this case, heart or king, right? So I'm going to call this H union king. That's what I want to find, right? Find the probability that the card is heart, or the word or suggests the union, right? Or a king. So this is, according to the formula booklet, it's probability of hearts plus probability of kings minus the probability of the intersection, hearts and kings, right? So I need to identify each of these terms. What is the probability of obtaining a heart? The probability for obtaining a heart in a deck of cards of 52 is, if you take a look here, there are 13 hearts, right? So it's 13 out of 52, which is a universe. We cannot simplify this as heart is, as 13 is a prime number. Okay, then we need to find probability of kings. If we find the probability of kings, then we know that there are 4 kings in the deck of cards of 52 cards, right? So 4 out of 52 is the probability of obtaining a king, right? And we know we can find this value, the probability of heart and king. We know that in a deck of 52 cards, there is only one king of hearts, which is this one over here. There's only one. So the probability of obtaining both a king that is a heart, or a heart and a king, is 1 out of 52. There's only one possibility in the deck of cards. So once we know these 3 pieces of information, we can find the union. What is the probability of heart or king, right? So the probability of heart or king is equal to 13 over 52, which is probability of hearts, plus 4 over 52, which is the probability of kings, minus 1 times the intersection, which is 1 out of 52. Without using calculator, we can say this is 17 minus 1, 16. So this is equal to 16 over 52, which we can simplify, and this would be, let's see, divided by 4. Yes, divided by 4, this would be equal to 4 over 13. Right? So finally, the probability of hearts union kings or kings is equal to 4 out of 13. I wrote it that way because I don't have enough space, but you know that is a fraction, okay? 4 out of 13. If you want to visualize this as a Venn diagram, maybe it'll be easier for you to try to solve exercises like this. You can do it this way. If we do a Venn diagram for this situation, we're going to have, let's do the rectangle for the universe. So this is a universe, right? Inside the universe, we're analyzing 2 options, heart and king, right? So we're going to have 2 circles. One circle will be for the heart. So this is heart. And another circle will be for kings, right? So heart and king. We know that there is one a heart, which at the same time is a king, right? So we can write the value here 1. In the intersection is 1. There's only one king of hearts, okay? And how many hearts are remaining in the deck of cards of 52? We have 12 left, right? Which are not king of hearts. So we're having 12 here. So the addition of these two is 13, which is correct. There are 13 hearts in the deck. And how many kings are we left with? We're left with 3 kings, right? In total, we should have 4 kings, and so that's fine. So my universe in this case is 52. I have 52 playing cards, right? So outside of the circles, I have the remaining cards. That would be 13, 16, 52 minus 16, that's 36. I got 36 cards outside of these two categories, right? So if you visualize this, it's easier to conclude that the probability of heart union or heart or king is equal to this addition divided by the universe, right? So this is 12 plus 1 plus 3 divided by 52. And this is equal to 16 out of 52, which if we simplify will give us 4 out of 13, right? Which is exactly the same result we got here. So that's another way you could solve this type of exercises, right? You can make a sketch of the Venn diagram to analyze what's happening, and maybe it will become easier to find the result that you're looking for. But I'm showing you both ways for you to know that there are different ways one can find a probability, using formula or drawing a Venn diagram. Okay, there are some cases in which drawing a Venn diagram becomes much more complicated and it's rather easier to apply the formula. For example, in this example that we're going to see now, it says, if A and B are two events such that the probability of A is 9/20, and the probability of B is 3/10, and the probability of the union is twice the probability of the intersection, then find all of this, okay? So you see that in this case, we are already given the elements of the formula, right? Probability of A, probability of B, and we're given this information which we're going to see how to use, but it looks easier to work with the formula directly rather than trying to build the Venn diagram in this particular case, okay? So let's analyze this. From the formula booklet, we have the formula which we have seen previously, that the probability of, I'm asked to find the probability of A union B. So I'm going to write the formula. A union B is found by I'm using this formula. So it's probability of A plus probability of B minus probability of the intersection, right? That's what combined events tell us, right? So I already have this, and then I have a relationship for this variable and this variable, which is the probability of A union B is twice the probability of the intersection. So what I'm going to do is I'm going to replace this value for its equivalent, which in this exercise is 2 probability of A and B. So if I do that, I'm going to have 2 probability of A and B is equal to probability of A is 9/20 plus probability of B, that's 3/10, minus probability of the intersection. So if you look at this, you will see that there's only one variable here, which is the probability of the intersection. If you want to make this easier and less confusing, you can call this, all of this term, you can call it x, right? This would be x, this would be x. So if I rewrite this expression, this would be 2x equals 9/20 plus 3/10 minus x, right? And now I can solve for x. I can take these x to the other side. I'll have 3x equals 9/20 plus 3/10. If we're not using calculator, I would rather amplify this fraction over here in order to get 9 over 20 for the first one, plus if I multiply all of this by 2, I will get 6 over 20, right? 6 over 20 is the same as saying 3/10. So this is much easier to add, right? We're going to have 3x equals 9 plus 6, that's 15 over 20. And we can simplify this, right? 15 over 20 is the same as, if I divide by 5, it's 3/4, right? So 3x is equal to 3/4. So the value of x would be, if I take this 3 dividing down here, it would simplify with the 3 which is on top. So this would be 1/4, basically, right? So the probability of the intersection, which is what we called x, the probability of the intersection A and B is equal to 1/4. Okay? But that is not what we were asked to find. We were asked to find the probability of A union B. But from the exercise, we know that the probability of A union B is twice the probability of the intersection. So to find probability of A union B, I just need to multiply this by 2 times 2, and this would give us 2/4, which if we simplify would be 1/2, right? 2 and 1. So the probability of A union B is equal to 1/2. Okay, so that's the probability of the union in this case. And that would be it for part A. I forgot to write A. Let me write A here. Okay, then we have part B. Let's see if I have space to work with that. I'm gonna separate this right here. Okay, so then I have part B. Part B says the following: find probability of A union B, probability of A union B not, right? Not A union B. If I already have the probability of A union B, which is 1/2 or 0.5, then the probability of A union B not is its complementary, right? So I know, if you don't remember from the formula booklet, here you have the formula. If I have an event and its complementary event, then the addition of both should always give 1, right? So that's how I'm going to find probability of A union B not. We know that probability of A union B plus the probability of its complement, A union B not, should always equal 1. So this is 1/2 plus the term I want to find, A union B not, and this should equal 1. So probability of A union B not, if I solve for that, it's 1 minus 1/2, which is 1/2, 0.5. Okay, so that's the probability of A union B not. It's a coincidence that it's the same value as this, but it is not always the case. Okay, in this case, in this exercise, it's a coincidence. So maybe I'll take this up here to save some space right there. So I'm gonna do part C down here. Okay, so part C, I want to find the probability of A intersection not B. A intersection not B. For this particular case, for intersection of A and not B, it may be a good idea to sketch the Venn diagram, right, to see what's happening. Okay, so I'm gonna make the, let's see, yes, I have all the pieces of information. I already know that the probability of A is, from the exercise, 9 out of 20, right? 9 out of 20. Which if I write as a decimal, this is 0.45. Then I already know probability of B from the exercise, which is 3 out of 10. That's 0.3. If we write it as a decimal, we already know the intersection A intersection B, which is this value over here, 1/4, which is the same as saying 0.25. 0.25. And with that information, I should be able to do my whole sketch, right? Because if I do the Venn diagram here, I'm going to do the rectangle. We know that we are going to have two circles, right? Two events. Event A and event B are my only two possibilities. So A and B. We already know the intersection is 0.25. So I'm going to write here 0.25. Then if all of A is 0.45 and I already have 0.25 in the middle, right? Then what I have left is 0.2, right? Which is 0.45 minus 0.25. And only B would be 0.05, right? Because it's 0.3 minus 0.25. Okay? And if I already, well, in this case, the universe would be 100%. So the universe is 1, okay? So what I have left outside of the circle, of the circles actually, is this, right? Probability of A union B not, which is 1/2, which is 0.5, if we write it as a decimal. So now it'll be much easier to find this, right? The probability of A intersection not B. So if I'm looking for the probability of A intersection not B, like this, where is this in the circle? In the Venn diagram, sorry. So A is all of this, right? What does that have in common with not B? Well, not B is everything that is outside of B, basically, right? So what do they have in common? They have in common this part over here. Let me do that with a highlighter for you to understand this more clearly. Let me highlight, let's say A with yellow. So A is all the A circle, right? Like this. Then B, not B is everything that is outside of B. So I'm gonna paint everything that is outside of B, and we would have something like this. Like this. We're not touching B. There you go. So if you take a look at this, you'll see that what region was painted by both, the region that was painted by both is this, let's say media luna, right? Half moon over here. So the probability, and that would be the what we're looking for, right? The probability of A intersection not B, by looking at the Venn diagram, is 0.2, and that will be the result for this exercise. We don't need to show any process anymore, because we already did the Venn diagram and we made the deduction from that. Okay. Yes. So you see that in some cases it's more convenient to work with the formula directly, but in other cases, like in this one, it's better if you work with the Venn diagram, right? There is a way you could solve this using formula, but it gets much more complicated, and I don't recommend getting into that, right? As long as you manage the concepts and you're able to effectively draw the Venn diagram, then this method is much better than actually applying formula. It's always better if you try to go for the reasoning way rather than the formula way, right? I always prefer that method. Okay, so I think I'm going to leave the class here just to not make the video too long. For the third part of this video, we're going to talk about mutually exclusive events, and then you're going to keep on practicing with Venn diagrams, okay? So I hope this was clear enough for you. If not, please let me know. We're going to cover doubts in future live sessions. See you, juniors.